Hello, YouTube. This is Mr. Bakari, and today we are going to talk about something very important that applies to all of your high school math classes and beyond, and that is simplifying radicals. This is such an important concept. You've got to do it all the time when you're simplifying expressions, and there is some confusion to it. So I'm going to break it down for you like this, okay? The first thing I want you to do, if you're struggling with this, is just get a running list up top on your paper of all the perfect squares 1 to 100, okay? We don't need one, so we'll start with 4, 9, 16, 25, 36, 49, 64, 81, and 100, okay? So there's all of our perfect squares through 100. Now, simplifying a radical. So let's look at a radical. How about the square root of 81? Well, the square root of 81 is what we would call a perfect square, right? 9 times 9 is 81. So to simplify it, you just simply take the square root and you're done. Those are easy. But what we need to think about is the ones that are not perfect squares. Like, let's say the square root of 45, okay? Not a perfect square, but it can be simplified. So how do you know it can be simplified? What you're looking for is the largest factor of 45 that is a perfect square. If there are no factors of 45 that are perfect squares, it can't be simplified. It's as simple as that. So let's look at our list up here. 45. The largest factor of 45 that is a perfect square is 9, right? Because 9 times 5 is 45, all right? So then you take that perfect square and you take its square root and you bring it out front. So the square root of 9 is 3 and the 5 remains under the radical. Okay? So that's 3 square root of 5. That's the simplified radical. All right? It's as easy as that. Let's look at another one. How about the square root of 72? 72. Okay? So let's think about what factor of 72 is a perfect square factor, the largest perfect square factor of 72. Now you might think, what about 9? Well, 9 is a factor of 72 and it is a perfect square, but there is one that is larger, and that would be 36, right? So we want this to be a one-step problem, right? We want to simplify this in one swift step. So we're going to break this down like so. We're going to take the square root of 36, bring it out in front, which is 6. The 2 it stays under the radical and 6 square root of 2 is your simplified version. Now, this is an equivalent. So if you were to put this in a calculator, the square root of 72 would round to the same as the 6 times the square root of 2. Okay? It's like simplifying a fraction. All right? Let's look at another. How about the square root of 56? Now, if you want to try this one on your own, pause the video and give it a shot. Okay, so the square root of 56, as I look up there on my list, the largest factor, surprisingly, is 4. There's nothing bigger than 4. So 4 times what is 56? That would be 14. Okay, and then we'll pull our square root, which is 2. Leave the 14 under the radical, remains irrational. 2 square root of 14 is the simplified radical. And it's as easy as that. Okay? But just like some fractions, some radicals can't be simplified. Let's take the square root of 7, for instance. The square root of 7 only has two factors, 7 and 1, none of which are perfect square factors. So the square root of 7 cannot be simplified. So you simply leave that the square root of 7. Okay? So I hope, I mean, it's a really simple concept. Hopefully I broke it down a way that you can think about it and make it really easy and you can utilize these tools I've given you and hopefully be successful in your math class. All right. I will see y'all next time.